Hi everyone and welcome to this new video series all about probability. So probability is the mathematical language of uncertainty. We use it to quantify how likely something is to happen when we don't know the exact outcome in advance. So in this very first video we talk about the vocabulary. So the first term you meet in probability is the random experiment. The random experiment. So how to define it? Simply, it's an action or a process where the result cannot be predicted with absolute certainty. I'm not sure about the result. An experiment where we know all possible outcomes in advance, but we cannot predict with the certainty exactly which outcome will occur on any given trial. For example, tossing a standard dice, we know the result will be something between 1 and 6. So 1, 2, 3, or 4, or 5, or maybe 6. But we don't know which one it will be before throwing. Also, if I flip a coin, I know I'm sure that the result may be a head or a tail, but I'm not sure which one of them will be we will get in this experiment. The second term is the sample space, or simply omega. Omega is the set of all possible outcomes of a random experiment. In our example here, our omega, which is our sample space, is simply all possible outcomes. So it is 1, 2, 3 until 6. This is our omega, or sample space. Then we have cardinality. So cardinal is simply the total number of elements in a set. In our here experiment, the cardinal is 6. We count the number of elements inside this set. This is the cardinal, so it is 6. Now we have also what we call event, which is a subset of the sample space, and it's the specific outcome we are interested in. For example, if A is an event that tell us we get an even number after tossing a dice, so this result can be, or the outcome can be 2 or 4 or 6. So A is 2, 4, 6. It's a set. It is a subset of omega, and the cardinal of A is simply the number of elements in this set, which is 3. Now in terms of probability, if I want to find the probability of A to happen, so it's the number of favorable outcomes, which is the cardinal of A, 3, divided by the cardinal of omega, which is all the number of all possible outcomes, which is 6, and we get 0.5, which is 50%. So the probability of getting an even number is simply 50%. Now let's see type of events. So first we have a simple event, elementary, which means this event contains only one element. For example, rolling a 3, so we get the number 3 after tossing the dice. We get 3. So our event here, E equals 3. It has only one element. The set has only one element. This is a simple event. When we have more than one element, we call it compound event. And then we have, in terms of possibility, we have the impossible event, which is the empty set. That means this event contain no outcome, so the cardinal is simply 0 and the probability is 0. Then we have certain event, so the entire sample space itself, which is simply omega. So the cardinal or the probability of a certain event is the cardinal of this event, which is same as cardinal of omega. So it is card omega over card omega, which gives 1. Example, so rolling number less than 7. We know that if A is rolling number less than 7, we know that all the number in omega are less than 7, so it is omega. In the end, the probability of A is cardinal of A, which is the same as omega, so we can write it directly. Omega divided by card omega, it gives 1. So the probability of certain event is 100%. The probability of impossible event is 0. Now let's see some operation on events. We start with the intersection. So the intersection of two events, A and B, is the event that both A and B occur at the same time, and the notation is like this: A inter B. For example, rolling a die, let A be rolling an even number, so A contain 2, 4 and 6, 2, 4 and 6, and B is another event that says rolling a number greater than 4, which means B contain 4, 5 and 6. So the intersection A and B simply is what the element that we find in A and we find it in B at the same time. In this case we have 6 here, because 6 belongs to A and it belongs to B as well. So 6 is the intersection of A and B. Now for the union, A and B is the event that either A occurs or B occurs or both together, which means A alone or B alone or both together. And we write it like this: A union B. An example. So with the same example, we have A that contain 2 and 2, 4, 6, and B contain 5 and 6. So A and B together, so either A alone without B, which is 2 and 4, or B alone, which is 5, or B and A together, which is 6. So everything we find here is A union B. So it is 2, 4, 5 and 6. One important thing here is the cardinal of A union B is not just card of A plus card of B. If we do this, we get 3 plus 2, we get 5, but that's not true, because we know that 6 is repeated in A and B, so it is repeated twice. We need to subtract it once, so minus the A inter B, minus the intersection of the two events, so minus 1, we get 4. That's correct, but this one is not correct. And if we calculate the elements, so we have 2, 4, 5 and 6, we get 4. Again, if we take just the cardinal of A, which is 3, plus the cardinal of B, which is 2, we get 5. This is not correct because 6 here is repeated twice. So that's all for this video. In the next video we talk about the relationships between between events. So thank you for watching. See you in the next video.